Buenas, estamos de vuelta en Argentina, estamos de vuelta con los videos y perdón que he estado tanto tiempo ausente. Estuve un mes entero en Europa, fui a la KubeCon que me invitó la gente de Cast.AI, estuve ahí de vacaciones, corrí una maratón, hemos aprendido muchísimo sobre Kubernetes y sobre maratones en abril, así que no puedo esperar para mostrarle todo lo que he aprendido y todas las cosas que están saliendo en el mundo de los contenedores, en el mundo de Cloud Native. Una de las cosas que no son tan sorprendentes que aprendí durante la conferencia de la KubeCon es el uso de AI, de la inteligencia artificial. A ver, seguramente ya todo el mundo está cansado de escuchar esto, pero la realidad es que la inteligencia artificial está cambiando o ya cambió la forma en la que la gente trabaja. No solamente en ingeniería, sino en diferentes ámbitos. Y la forma de ahorrar dinero no se queda afuera. Cast.AI hace rato viene usando inteligencia artificial, pero ahora en las nuevas versiones cada vez lo usan más. Hace un tiempo Cast.AI publicó un reporte 100% gratuito, que lo pueden ver, está en el link en la descripción para que se lo descarguen, que analiza más de 200 clientes que ellos tienen y pudieron ver cosas muy interesantes. Les voy tirando un par de spoilers de las cosas que vieron. En promedio, sus clientes usan el 10% del CPU de lo que están pagando. O sea, que se están pagando $100 por mes, están usando solamente $10 de eso con respecto al CPU. Que en mi memoria está un poco mejor, creo que está en 23% o algo así. Esa es una de las cosas que encontraron en estos reportes. Después hay otras cosas muy interesantes que las voy a mostrar también cuando analicemos un poquito el reporte más, que reflejan cómo la gente ahora está usando AI, o sea, el uso de GPUs, por ejemplo, para sus infraestructuras. Y también Cast.AI obviamente se ha adaptado para poder ahorrar dinero teniendo en cuenta este uso ahora más intensivo de infraestructura con GPUs. Y una de las cosas más interesantes que se discuten en esta charla que tengo con Laurent, una persona de Cast.AI, es el uso de la inteligencia artificial. Pero realmente el uso de la inteligencia artificial de una forma que te ayuda a mejorar. Y una de las formas que más me gustó de que lo explicó es que la inteligencia artificial es como un intern, o sea, como una persona un junior, una persona que está trabajando en tu empresa, que está obsesionado con su trabajo y trabaja 24 horas al día en solamente una sola cosa. Y esto me parece que es una excelente forma de describir la inteligencia artificial. Porque nosotros como humanos a veces estamos obsesionados con algo. Por ejemplo, queremos liberar costos, queremos bajar los costos de nuestra infraestructura. Bueno, sí, por un par de días, por un par de semanas, nosotros vamos a estar metiéndonos ahí, tratando de liberar recursos, de bajar los costos, pero va a llegar un momento que nos vamos a cansar, que nos vamos a fatigar. En cambio, la inteligencia artificial nunca se va a cansar, siempre va a estar obsesionado con eso y va a tratar de arreglarlo. Así que creo que es muy interesante la forma en que Cast.AI usa la inteligencia artificial para mejorar los costos. Y otra cosa interesante que se charló sobre la gente de Cast.AI es una feature que yo realmente necesitaba en mi empresa anterior cuando usaba Cast.AI en producción. Así que quédense para ver todo eso y recuerden que la charla va a estar en inglés, pero pueden elegir subtítulos ahí para elegir en español como quieran. Nos vemos.
So yeah, I noticed that you posted a report a few weeks ago. Can you tell me a little bit about that?
Yes. So here's the way the report was structured. We have about 2,100 organizations that are on Cast.AI. So we look at the state of those clusters before we onboarded them, so before we made them more efficient. So it's a true representation of the world of Kubernetes today. And this is done on 3 cloud providers, AWS, Google, and Azure. And because of the size of the organization and the size of the clusters, it's 50 CPUs and more, it's a true representation. This is not a survey, it is really a statistical analysis. So here is a number. On average, you are not using more than 10% of the CPUs that you have, on which you have deployed this cluster.
Not 10%. Using, so you're paying 90% more than you should?
Yes. But if you think about this, it means that your over-provisioning is 10x. I mean, 10 times 10 is 100. So this is the number I'll show you. Yeah. I'll show you on screen. So think of this. You have 100 CPU in your cluster. You probably only use 10.
Why is that?
On average, right? So probably at some time during the day, it's a little bit higher, and sometimes during the night, it's a bit lower. But it's no more than 10%. Memory is a little bit better. It's 23%. But it just means that you over-provision exactly by 5 times for memory and by 10 times for CPUs. So this is not great. If you think about that, it translates into cost as well. So those clusters are not greatly efficient. That means that out of $100 you spend on one of those providers, you're only using 10 of those $100, and the other $90 is just a gift.
Yeah.
It's a great gift. But you have to think this way, right? So, and because this was done on such a large amount of clusters, it is millions of CPUs, then it really is a statistical evidence. We also look at this by cluster size to see if there was a difference. So on 1% of the largest cluster, think of this as many tens of thousands of CPUs, and we do have clusters of that size. The over-provisioning is 35%. Why is it higher for those large clusters? Because the companies who have this kind of deployments spend a lot more time in making sure those clusters are working. It's still 3x, but it's not 10. So the rarefied world of extremely high-end, extremely large clusters, yes, it's not too bad.
Okay.
The vast majority of us, 99% of the rest, is not that great. That's the point.
Okay, and why is that? I mean, why are people wasting that much money? Is it humans? Is it?
Yeah,
yeah.
It's a great question. So I can tell you one thing: it's not the cloud providers.
Okay.
So we look at AWS, Google, and Azure, and we see if there was difference, and there's almost no difference.
Oh, interesting. Okay.
It's interesting, right?
Yeah.
So AWS, Google, and Azure, it's the same. It's between 9 and 12 or 9 and 11. So it's not.
Makes sense. I mean, because obviously you set up the memory and CPU limits by yourself. It's not the cloud provider that sets up.
Exactly, and it's not the fact that they don't provide you the tools; they provide the same tools.
Yeah.
They're very similar. Kubernetes is open source, so at the core, so it's all the same. The reason is that it's impossible to run this manually by humans.
Okay.
That's the reason. Because it's the same for the cloud provider. It's not the tool they provide. It's Kubernetes that is the issue. It's the difficulty of running this, of managing this by hand. That is the problem. Great for us. That's what we fixed. But you see the point, right? It's not. Oh, and one more thing. It's not that we don't know about it, or that our colleagues try to improve this. They really cannot. So I'll show you an example. You see here. This is how it looks like. So this blue line here is the CPU request. Yep. It's just a screen. It's a Grafana. I love Grafana. It's a Grafana screenshot of one workload.
Okay.
One container, one pod. So this container, the settings was 0.3 CPUs. That's called the CPU request. So that's the amount of CPU that is guaranteed by Kubernetes to run this. The green and the below lines is what you use. Yep. The space between them is just a gift.
Oh, yeah.
You're not using it. Yeah. It's waste, yes.
You are paying it,
yes.
Which is worse.
And you see, this is graphical. So they all know that. Like we talked about this with our users. It's a very well-known fact that it looks like this, but because it's hard to monitor this, and it's hard to act as a human think you have 10,000 of those. Yeah. It's impossible to. And this is what happened. Here you see when I put the activation, this is what happened when you run some form of automation on top of it.
Okay, I do have a question because I see this all the time. I mean, in my previous company, we had a similar graph, right? Like a really low CPU users and a really high request.
Yeah.
But the thing is that most people do that because they are scared and they don't want to be like being close to the limit in case that you have like a spike in traffic. And actually, I see a spike there on your graph, like between February 1st and February 2nd.
Here,
it's a spike. It's still below the line, right?
Yeah.
But you still see a spike. And then after, when you lower your request, there are some spikes over, right? So that might be a little scary for people because...
No, it's by design. So you see CPU is elastic.
Yeah.
Elastic means when you I'll explain to you how that works, but when we design this, we take it into account a probabilistic analysis of the percentage of time you are above and the percentage of time you are below. Okay. So what you see here is actually an agentic framework in action. So it's an agent that does that. The agent does the exact same thing as a human would do. So us as human, we kind of see this graph before activation. And it's kind of too high. And as human, it's kind of graphical. Oh, there is one peak. Yes, it's between 1st of February and 2nd of February of this year. But because it's only one peak, it feels like, okay, for maybe 5 minutes, I need 0.15 CPUs. Yeah. But the rest of the time I don't. I probably have this in my node anyway, because node have space also. because they are not always 100% full.
Mm-hmm.
So as a human, you kind of think, yeah, I probably can reduce this. But because you are looking at this maybe once or twice a month, there's no way in the earth you would even see that.
Yeah.
Here, this is an agent that does it. It was trained to do the exact same thing as a human would be trained.
Right. So the Cast.AI agent is running in your cluster.
Yep.
And not only, I mean, before when we talked with Leon in the previous interview, it was just like basically carpenter,
Yep.
right? It was just provisioning nodes, right? With some technology that maybe makes Cast.AI to choose a better node for the moment. But this time it does some other things as well. It's actually changing dynamically the deployments and stateful sets and all of that, and changing the CPU and memory requests to make it more efficient, basically.
Exactly. And it does this every second.
Right.
That's the key. It's the same thing the human would do maybe once or twice a month, or maybe never, if they don't look at it anymore, which a lot of us do, not look at it anymore. Here, it's almost feel like you have someone, it's a smart entity that is obsessed with this, that do it every second on the 100,000 containers you have in your organization. They would never go for lunch, never sleep at night, and do this 24/7. It's exactly like this, and I explain this very often to our users so they get it. Say, oh, so that's what it does. Yes, it does the same thing you would do, but you don't need to do it anymore. Oh, it's not the same. You cannot do it every second.
It's impossible to do it for.
But that guy or that entity will do it for you. That's the beauty of it. Now think of this like that. And then, because we also have an agent that runs your autoscaler, it's still EKS or AKS or GKE, can even be on-prem. We run the autoscaler in the clusters too. When that happens, oh my God, this node is empty now. Because remember, it was reserved. So 0.3 CPU was reserved for this workload. So if this node is full based on that, then the node is full. But if you reduce that amount, then suddenly the node has space. Oh, then maybe we should replace it by something smaller. You see, it's this combination of we have an agent that runs the autoscaler, which is what you heard from Leon 2 years ago. Now we have an agent that also runs the workload right-sizing or the workload
it's the
autoscaler.
two sides. It's outside the node and inside the node.
And they are colleagues.
Yeah, of course.
But think like this. Really, they are actually colleagues, meaning they are both agents. They know each other. They know each other. So when that guy say, "Oh, I'm changing the CPU request," then that guy say, "Oh, thank you to tell me. I'm going to check if I can reduce, eliminate, or change the size of the node."
So it's letting one agent is talking with the other agent, letting them know what they're doing. It's not. They're not independent. They work for the same team and they're communicating all the time.
They work for the same team. And you know why we did it this way? Because that's how it works with humans too. That you have a team of 5 DevOps engineers, so some are specialized in some things. It's the same thing. That's why this works so well. And believe me, when you see this running, I call it irresistible. Like it's so cool to see it working. You say, oh my God, so automation is great. You know, a lot of people was always telling us, well, we have observability, you know, we use a lot of tools, it's great. We know we as people, the system will warn us when there is something to watch. Here, it's the same, except the guy or the entity who's watching it is watching it all the time for everything. You know, this may be an orange line inside your observability dashboard. Say, hey, you should, there's a recommendation that you should change the CPU request. There is no more of those. Everything is green because it's been changed as it needs. And the nodes will be resized as it needs. But think about this. If this node was, let's say, an 8 CPU node, and there was no availability, no spot instance available in your region, and now you change the size, and suddenly there is availability, you can see how deep you can go into making this more efficient. It could change the machine. It could change the type of machine. It knows that, oh, we just need, let's say, an Intel processor or an AMD processor. It even knows when to switch from Intel to AMD to Graviton or to ARM if required. And it knows, it means the agent, it knows this. So it always will look at the autoscaler agent We'll always look at the best machine that is the best fit for the job. So one of them is telling you how fit you are. The other one is saying, oh, you are fit like this, I'll reduce the size of your clothes.
Okay.
That's how it works.
Nice. And one question, because how does it work in the middle? Because, for example, if I make a deployment that changes the deployment request and memory, like if I have like a manifest that is hard-coded, let's say, does it catch it? It has like a webhook or something in the middle? So
there's several ways of doing it. So when it's stateless and you have a high duplication of this, it's okay to do immediate change. So it will restart and the container will restart and the restart will be a lot smaller.
Yeah.
If it's stateless or if you have maintenance window, then you can say, hey, capture all the data, but only do it once a day when everybody is sleeping.
Okay.
So you can select this. You can also say, hey, I'm okay that you make the change, but only make it when there is a significant impact. Let's say your cost, well, your efficiency will increase by 20%. Okay, do it there. But if it's not 20%, there's no need to restart anything.
Okay.
So don't do it. So we call it deferred mode. Deferred mode means do it smartly when it makes sense. If the number is significant, otherwise don't do anything. And maybe you do it only in between 2 a.m. and 4 a.m. Your time, or all the time, or only the weekends, or once a month. So you can really go deep into this.
Okay, so tell me a little bit about over provisioning. You were talking about that.
So this is what is also very surprising, and frankly, this one I was surprised. So here we spoke about, on average, your over provision CPU by 10x, and memory is a bit less by 5x, 23%, 4 to 5x. Okay, that's great. Well, except that sometimes it's the opposite.
Okay.
So remember, we have 2,100 more, about 2,000 organizations looking at it. We look at millions of containers. And we made a statistical analysis saying, is there sometimes under provisioning? And here's what we found. On average, within the last 24 hours, 6% of your containers ran out of memory.
6% of your containers run out of memory. Okay.
In translation, it means for 6% of your containers had a memory utilization that was higher than memory requested.
Okay.
So potentially run out of memory. 6% is a lot. So it's a lot because the impact of running out of memory is dramatic.
Memory restarts your pod. It's not the same as CPU.
Yeah, exactly. CPU, you look at your bank account, you wait for 50 more milliseconds. Yeah. You don't even notice. Nobody does.
But it's fine.
But if you have to log in again, oh God, that's not great. So the poor utilization. So I'll show it to you. You'll see. Yeah. You see how it looks like. What you see here is the green line. So this is also a screenshot of Grafana. The green line is the memory utilization. The blue line is memory request.
Okay.
This is what you see here is a very large pharmaceutical company.
Okay.
And you see the memory use is above the memory requested. I'm going to show you what happened when we turn on this agent. So here's what happened. So you see the activation line.
Okay.
As soon as we activated, the agent said, "Oh my God, I got it wrong.
Yes.
You need more memory requests." So it immediately increased it. And you see, this is typical of AI engine. It does one increase, then a few hours later or a few minutes later, it did another one, and then another one.
It does it slowly.
Yes, because it's like us. So it's thinking, oh, is that enough? Oh, no, it's not enough. Okay, I'll do it more. Is that enough? No, I'll do it a little bit more to be safe. Another thing you notice, before we activated the engine, you see the line is not straight. It's
spiky.
It's the restart. It's all the restart. So say I don't have enough. I break and I start again. That's
right, because this is the average across all the pods.
Yes.
So if the memory usage goes down, that doesn't mean that a pod maybe got restarted.
Exactly. And after the agent was activated, it's a green line. It's a flat line.
Interesting.
So here is what we see with our users. We say to them, look, I know because we are all human, we're gonna over provision anyway, CPU by 10x. But you really have to pay attention because sometimes 6% of the case is the opposite. Remember, average is terrible. So the average masks the issues.
Yep.
And running out of capacity is a big problem for memory. And that's the impact. So a lot of people, a lot of our users say, oh, so you're going to make it more efficient, meaning reduce my cost, which is great, so I can spend money somewhere else.
Yeah.
And there will be a trade-off, it will be a little bit slow. And we tell no, it will actually run better.
Yep.
And again, why? Because we're not trying to reduce your cost. We're trying to make it efficient.
Okay.
And we're not doing it differently than you would do it as an engineer. We just looked at the way you did it, and we made an agent that does it, except it's obsessed with it, and it runs all the time. And you know what the cool thing is? The human is always in control. So think of this as what the human does here is it fixes the boundaries. It says, you know, I'm okay to be, I always want to be a little bit above the memory. Can you give me 10% buffer? Or you can even say, can you tell me what the buffer should be? Yeah. We can say, can you tell me, can you make it 10% above always? So you see the DevOps engineer now becomes the analyst. They are thinking, they are describing how they would like the ideal situation to be. It's no different as you have an intern and you're telling the intern, you're teaching, right? The intern, hey, I want you to do this, and do that.
You try to simplify it to him.
Yeah. Right. And you're doing the same for an AI entity. You are saying, this is how I want you to behave, what do you think? And then you adjust this over time as you feel how things are. So you become an analyst. You see, you stop being a factory worker, which is great to be, and you start to be the engineer that's looking at it and thinking, how can I do that better? Yeah. Or how can I ask this agent to make the life
easier? It's like the discussion about AI getting our jobs. Yeah. And it's not like that. It's evolving, right?
Yes, this AI agent is helping the humans. It's not the other way around.
Right.
And the humans are there. They are essential because they are the one telling the agent, you know what, this is a checkout page. Yeah. For the checkout, you know, I want you to be cautious. Be careful for the checkout. You need the human to say this.
Right. Yeah. So the human is needed to set up the boundaries and to basically tell the AI what do we need and let the AI to do all the work. Exactly. Because it's impossible for a human to manage thousands of containers or nodes. Okay. So
it's cool. And remember, because we have another agent, his name is autoscaler.
Okay.
You run out of memory. Oh, there's no more memory in the node. Don't worry, I'll create a new one. Hey, can you please create a new node? Yep. Then this agent say, oh, yeah, I'll do it now. Oh, I will find the best one. Tell me what you need. I will find the best one for that.
Right. The cheapest one with maybe memory optimized or CPU optimized or even Intel, AMD, depending.
Or GPU optimized. You see, the cool thing of controlling both the autoscaler and the workloads at the level of the workload and at the level of the node is that these two guys are talking to each other and they help each other. Mm-hmm. This is why we often recommend that if you want to make your cluster fully autonomous, then use these two things. Use all the tools you have at your disposal, not just a piece of it, not what I call a feature, but a platform. And that is becoming a platform. A platform says, hey, I get your Kubernetes thing. That's the platform. I get it. I'm taking care of it. Tell me how you want me to behave. Me means the agents, and me as the agents, I'll do them for you.
I think this is great because I think this is the missing link that we had before. Because I remember, again, from a previous company, we had this problem. We saw all of the recommendations and said, yeah, you're spending 80% more on these workloads. But for me, there was like 55 or 60 pull requests that I had to make to change all of those memory requests and CPU. And I didn't want to touch them because they were production workloads.
And that's it.
So there was a lot of work. I mean, it was like, okay, Cast, I mean, you're giving me more work now. And now with this agent, you can actually just leave it to the AI and it can do it itself.
And you know, Pablo, sometimes we tell our users, don't even try to adjust the request. It will figure this out for you.
Right. You just
Because
leave
they
it without any CPU request memory?
we just say, just put whatever you want.
Yeah.
Because it doesn't matter, it will be changed in 30 minutes.
Right.
And then it will be remembered after this. So next time the container comes, it knows what it should be.
Is there a way to maybe prepare, let's say that, I don't know, Black Friday is coming up.
Yeah.
You said that you just put whatever you want, it will remember. Okay, but maybe it won't remember last year, or maybe it doesn't have the data from last year. Is there a way to like say, okay, please be careful this time because we need more?
That's exactly how it works. Please pay attention.
Okay.
That's it. Please pay attention to it. What you can do also is you can, instead of having the percentage above being a number, you can say figure out the best number, and this will be adjusted.
Okay.
Remember, the one thing the agent does, which is the same as human, is we look at the acceleration of things. So if there is a memory, if there is a certain acceleration of resource need, then it will accelerate the answer. Yeah. So what you saw is workload, nodes, impact, changing request.
Yeah.
We asked the agent another question.
Okay.
And the question is the following. This is very surprising. The question was, is there a better place to run my AI workload?
Okay.
In English, is there a better place to run my I have some AI workload. Why? Oh, they need GPUs. That's how I defined it. Oh, okay. So if I need GPUs, is there a better place to run my workload that requires GPUs? A better place means could mean more efficient. It could be simply as find me GPUs, por favor. I don't have any. No, it really is like this. It's very hard to find them. It's hard to find them for a long time, especially the A100, the H100, this new machine. So here's the answer. And we did this answer for 2024 up to February of this year, of 2025. And so we look at this written there. We look at the best place to run AI workload in 2024 AWS. So we did it only for AWS just to show an example, and for a machine called P4D, which is one of the big GPU, expensive GPU. And here is what we found. In January, the best place to run AI workload was US West 2A.
So what? Okay, so what?
But you see, it changes.
Okay, it changes. Yeah, that's amazing. Why is it better? Because it's cheaper. How do you find best?
So there's two parameters that was important. One is, do you have some?
Okay, so yeah.
But the other one is, do you have spot instance?
Oh.
Because they are. You see, when I show this to people, say, no, but it's impossible. There's no spot instance. There's no such thing for GPUs. Come on, everybody that's looking for them, they don't exist. Well, they do, if you know where to look. Of course, we can't, because we are human. Are you going to look at it every 5 minutes? Oh, there's GPUs here, I need to grab them. No, but if you use an agent that is obsessed with this, yes, of course, you will. So in January, it was West 2. Between February and May, go back to the East Coast, but not 2A, it was 2B, the average for this period. Between June and July, it's Tokyo.
Interesting.
It's Northeast to 1A. From August, it's Korea.
Wait.
Yes.
Is it because of the weather? Because maybe it's colder. It's colder in the upper hemisphere, so maybe GPUs are cheaper there.
It's not. It's because of availability. So AWS spot instance on AWS increase when there is pressure on availability, and until they interrupt you. So it just means that there was a lot of pressure, meaning a lot of users in the US. Look at this column now. If you follow what the agent tells you, this is a number of times cheaper you are over on demand. So think of on demand means if you don't have reserve instance or savings plan. So if you knew that in January it was US West 2A, you would spend 10 times less on average compared to the average of on demand for that machine.
That's amazing, because
AWS.
obviously those machines are really expensive.
Yeah,
so 10x
10x is a lot of. But no, think of this as like that. Let's keep the 10x. Remember the over provisioning of 10x?
Yep.
Well, it's 10x of 10x.
Yeah. It's 100.
It's 100 times.
Yeah.
Of course, not always. And the
Yeah.
GPU utilization is slightly different. But you see the impact of it. But let me tell you one thing now. Think of that. If I was using an agent and asking the agent, please find me the best place to run my GPUs, my AI workload. And then if you would tell the agent, hey, if you find one, move it, then that's your settings.
I see.
You see why having something fully autonomous can do that?
Yeah.
That is what we can do. Remember, we run the autoscaler, means we have an agent that runs the autoscaler.
Yeah.
That's the agent that decide where are the nodes and spin them. It's EKS, but it decides. So now if you apply that thing, the third, let's call it the third agent, that is find the best place to run my GPU workload. You combine that with the agent that run the autoscaler and the agent that run the workload autoscaler, that's your 10 multiplied by 10.
Nice.
That is so cool. That's kind of the ultimate. Like there's no more autonomous than this after this. You know what? We tell some users, well, you don't even need to know where to run this. Give me boundaries. So if you're in Europe, you probably will tell me, oh, I'm okay to run any place in GDPR. That's been from Paris to Milan. And please go figure this out within this. You're going to have some network cost. It knows. So it will only move if the benefit is higher than network cost. If you're in the US, you probably will be okay between US East and US West. It's like 30 or 50 millisecond difference. For LLM, it doesn't mean anything. LLM takes a few seconds anyway. Nobody notices 40 milliseconds on LLM. If you're in Asia, then probably between Singapore and Japan, you're fine. But Japan has many regions also. So you see, as an analyst, you will define your level of comfort. And then within these boundaries, you can trust your new colleagues that will always find the best place within the boundaries that you define.
Awesome. This is great. And I do have a hard question. Does Cast.AI know about your saving plans? And what are you, because in my previous interview, they didn't have that feature yet. So for example, it always choose whatever were available and it didn't have any integration with my saving plans. Does it have?
And we call it part of the feed. So the same way as you would know as a human, the agent knows. So it will make decision based on it. So it does pricing arbitrage, not based on demand, but based on how much you pay for those machines, and it knows. But it can do much more than that. It can say, hey, if there is any reservations that I forgot to use, it knows and will use them first.
Right, of course.
So it will always maximize your. I call that the constraints. It will always maximize within the constraints. You know, we have some customers that says, my reserve instance, you reserve it only for database. I don't want them to be used for anything else.
I was about to ask you, does it have any, is there any point of having a saving plan if you're going to be using Cast.AI and just use spot instances?
Yeah, that's a great question. So what we advise customers usually is, during any application has what I call the minimum amount of compute necessary. Like your car has 10 liters of gas of fuel remaining. That's the minimum. You always need this. Or if it's a battery, you need 10% of your battery. So we look at the minimum during the day, and that's going to be your. And we advise, look, this one, you need it anyway. So buy reserve instance. They are cheaper than savings plan. It depends your appetite. So buy a reserve instance. You need them anyway. Try to not fix the type of machine so we can optimize from within. But you need this. What is above? It will figure this out.
Leave it to us. Awesome.
That's the idea.
Okay, Lauren, thank you very much for your answers. It's been great. So we're going to check it out, and we're going to leave a link in the description for the report so people can download it.
Good.
And it's free, right?
Yeah, of course.
And how can people check out Cast.AI?
Oh, just go to Cast.AI.
And they have like a demo. You can actually install the agent for free.
Yeah, you can install the agent for free. You can play with it for as long as you want.
Awesome. Thank you very much.
You're welcome. Thank you, Pablo.
Bueno, varias cosas interesantes se charlaron sobre esta charla. A ver, la cantidad de desperdicio que la gente está pagando, el 90% del CPU está totalmente desperdiciado. El tema de que hay algunas zonas que cambian el precio y son mejores para elegir en diferentes épocas del año, muy interesante. Y cómo el uso de GPU también está disponible con instancias spot. Y hablando sobre las instancias spot, estuve viendo el reporte, que de nuevo lo pueden descargar de forma gratuita, está en el link en la descripción para que se lo descarguen. Hay varias cosas interesantes en este reporte, ya hablamos de esto, el 10% de uso de CPU, el 23% de la memoria, el uso de spot instances que mucha gente se rehúsa a usar todavía, y la realidad es que no hay que tenerle miedo a las spot instances. Para aquellos que no saben, las spot instances son instancias que cuestan básicamente a la mitad de precio, lo estoy resumiendo muy rápido, pero básicamente cuesta la mitad de precio de la instancia normal, pero tiene una particularidad. En cualquier momento, el proveedor, ya sea AWS, GCP o Azure, te puede apagar esa instancia, ¿sí? Y te da una nueva. Obviamente, si estás en el mundo de instancias instaladas a manos, se te apaga la máquina, perdiste todo y fuiste, tenés que volver a instalar una máquina nueva. Entonces, en ese mundo no te sirve. Pero pensar en el mundo de Kubernetes, donde tus instancias son ganado, entonces apagar una máquina no debería ser un problema, ya que Kubernetes debería agarrar todos esos pods que están ahí y moverlos a otro lado. Obviamente, la instancia recibe como una señal y Kubernetes la puede capturar y empezar a drenar el nodo para que cuando la instancia se libere, o sea, se tenga que ir, se tenga que apagar, no esté corriendo nada dentro de ese nodo. Así que es muy interesante. Pero hay unas estadísticas muy buenas que, mirá lo que te dice, por ejemplo, las de AWS duran en promedio 7,6 horas, las de GCP duran 13,8 horas, casi el doble, y las de Azure duran 70 horas. Mirá qué interesante esta métrica, o sea, sabiendo que depende del proveedor cuánto duran esas instancias. Y aparte dice que en la primera hora, ¿sí?, de una instancia, el 50% de las instancias en spot son apagadas. O sea, si vos tenés 10 instancias, durante la primera hora, 5 de esas van a ser apagadas y las otras pueden durar muchas horas. Muy interesante. Obviamente en AWS estoy hablando, ¿no? Bueno, que dice que Azure también tiene porcentajes mucho más bajos de apagado en las primeras 12 horas. Y después tenemos disponibilidad de GPU en los diferentes proveedores, ¿sí? Acá tenemos los diferentes valores, el diferente tipo de GPU. ¿Dónde es más barato? Bueno, en Azure parece que son 15% más baratas que en AWS y en GCP son 28% más baratas que el equivalente en AWS. Muy interesante, muy interesante. Si corres spot instances en GPU, que por cierto sí existen, lo dijo Laurent, ahorrarías aproximadamente un 90% en Azure, un 67% en AWS y un 66% en Google. Muy interesante también. Hay varias cosas, bueno, esto es lo que mostraba recién, la disponibilidad en diferentes zonas. Otra cosa interesante e importante es el uso de instancias ARM. Les recuerdo que vos podés correr procesadores con x86, que son los Intel o AMD, y también están los ARM, que son los que corren, por ejemplo, en la Raspberry Pi, y los que corren, por ejemplo, en las Mac ahora, son todos ARM. Hay muchos teléfonos que corren ARM también, la mayoría. Así que se pueden correr ahora instancias en ARM y son mucho más baratas, en promedio valen el 50%, así que es muy interesante. Y esto, lo de las memorias, me pareció súper loco, el hecho de que al darle más memoria lograron más estabilidad, eso es genial. Así que bueno, esas fueron varias cosas interesantes con respecto al reporte. Díganme si les interesa después que analicemos el reporte completo y leamos uno por uno todos los puntos, porque me parece que está bueno, me parece que está bueno saber y no necesariamente es sobre Cast.AI. O sea, esto de reporte sirve para cualquier persona que ni siquiera use Cast.AI, le sirve, es data interesante. Así que chequenlo, de nuevo en la descripción, gratis para descargar. Finalmente, no se olviden que estoy sorteando todos los meses 3 personas que lo único que tienen que hacer es meterse a Cast.AI, hacerse la cuenta gratuita y probar el agente en un clúster. Es lo único que tienen que hacer. Lo único que tienen que hacer es eso. Y con ese mail yo después les voy a sortear 3 personas por mes y les voy a regalar una Raspberry Pi 5 y la vamos a mandar a cualquier lugar del mundo. Loco, no sé qué están haciendo que no prueban Cast.AI. Chequéenlo porque después de ganar una Raspberry Pi, que por cierto, Cast.AI, sí, a vos te estoy hablando, a mí no me llegó ninguna Raspberry 5. O sea, a mí no me regalaste una Raspberry, estoy con la 4 todavía, ¿puedes creer? La 4. Ya tiene como 5 años ya. ¿Qué estamos haciendo? Yo quiero una Raspberry Pi 5. Lo tenía que haber puesto en el contrato. Mala mía. Mala mía. Así que bueno, eso fue todo por hoy. Espero que hayan aprendido algo nuevo. Suscríbanse para más videos. Denle me gusta si les gustó. Denle no me gusta. Si en lugar de probar Cast.AI, probás Cast.AI. Es otra, una versión con P-Y, está hecho en Python. Y cuando probás haces la cuenta, en lugar de mandarte una Raspberry 5, te mandan una Raspberry 1. Pero no son tan ratas. Te mandan la Raspberry 1B, que tiene 256 MB de RAM en lugar... No, o 512. Creo que tiene 512 MB de RAM en lugar de 256. O sea, es la 1B. Ojo, ojo. Podría haber sido la 1. Podría haber sido la 1, pero no. Dijeron, che, no seamos. Tuvieron una reunión y dijeron, che, pongámonos las pilas, mandemos la 1B. Así que bueno, de última, tan malo no estuvo. Tan mal no estuvo. Pero bueno, pruébenlo, Raspberry 5, loco. Pruébenlo.